Hello everyone, my name is Alvaro, and in this video I will be solving one of the problems in the blind Leetcode 75 problem list. Today we'll be doing problem 200, which is called number of islands, and this is the first problem that we do in the channel that's of medium difficulty and what I would consider to be a medium difficulty problem. So this is a problem that you would expect to be asked in an interview. In fact, this problem and one of its variants, I got asked for both my interviews at Snapchat and Facebook, the two companies where I interned during college. And yeah, I would say it's very commonly asked. I've had a bunch of friends that have been asked this question or a variant of it. Another one that's very famous, I would say it's largest island, which is just a slight variation of it. So you might even be asked this question, and as a follow-up, edit your code so that it can also solve the largest island problem. But anyways, let's get to read the problem statement and a little bit of the code that we're given, which seems to be pretty much nothing. So yeah, let's see. Given an n by n 2D binary grid, which represents a map of ones, which represent land, and zeros, which represent water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay, so the island is if the lands are connected horizontally or vertically. So example 1, we have here, this will be an island because all these are connected horizontally or vertically. So we output a 1. Example 2, we have this island right here. And this chunk counts as a different island because it's not connected vertically or horizontally to this one. So diagonally doesn't count, only vertical or horizontal. And then here's another island. So we output a 3. Okay, seems pretty straightforward. Some assumptions here. We have the length right there of the grid, and all the pieces in the grid, all the entries in the grid are valid, so they're either a 0 or a 1. Great. So what approach are we going to use? So I'm going to discuss that now. So if you're working on this problem yourself, make sure to pause the video and just try yourself, and whenever you need some help or you want to compare code or the approach, then just simply continue playing. Okay, so the main idea here that we are going to use is to use a depth first search, or DFS, to explore the islands. And what I mean by that is that in this one right here, we can just explore every single piece of land. It really does not matter if you use a breadth first search or depth first search, but I think it might be a little bit easier to use a depth first search just for the sake of simplicity here. So we just simply explore every single piece of land on an island, and whenever we have explored all the pieces of land, then we increase our island count, which will be the variable that we want to return. Now, how do we ensure that we do not visit land, a piece of land twice? Well, there are two different ways of doing this. The first one that I will do will be the one that's not as space efficient as the second one, but I think it might be slightly easier to follow and easier conceptually. And the other one will use less space in memory. So the first approach will be to simply create a grid that is initialized to whatever values we choose. There's going to be two possible values. So in this case, I'm just going to use a Boolean matrix, but you can use, let's say, a matrix of zeros and ones as well if you want. But just for the sake of simplicity and visibility in the video, I will use Boolean values. So I'll initialize a matrix of the size of the grid, and it will be initialized to false. All the values in here represent, for example, this piece of grid has not been visited before, if this is false. And if this is false, then it has not been visited. However, if it's been true, that means that it's been visited, so we can ignore it. So whenever we do the depth first search, in order to avoid running to the same piece of land twice, what we can do is we can ensure to visit only the ones that have not been visited by checking with the Boolean matrix that we are going to define in a bit. And also, this will help us understand whenever we go like grid by grid, whenever we loop element by element, it will ensure us that we don't double count the island several times. So let's get started with it. The first thing that we're going to do is we're going to define the visited matrix. So, oops, sorry for that. And here we're going to use a list comprehension. If you're not familiar with list comprehensions, this might be a good example to use them first. So false for j in range grid sub 0. This essentially means that we are going to create a list that's full of false values, and there are these many values. So the length of one of the rows in this, and then we're gonna do this same thing I times, this should be length, there you go, for I in range length of grid. And we will repeat this thing that I just mentioned before, I times, where I represents the number of rows that exist. So for example 1, there will be 1, 2, 3, 4 rows full of values false, and each row has 5 elements. You can pause the video here if you want, maybe review a little bit of list comprehensions, but that's pretty much the gist of it. Now, what's the next thing? We have defined that, and we want to return the number of islands. And now we can also define the method that we want to use. So somewhere in here, let's say define DFS. So what are we going to need for that? We are going to need the current island that we're going to visit. We're going to definitely need the grid. And then we're going to need the visited matrix. And if we need something else, then we can definitely just add some. Let's do it like this in DFS. I like to keep methods in lowercase. That's just a camel case standard. So here we're going to start by checking. So the idea behind the DFS is if we are in a piece of land, right? Then we can explore the neighbors. But if we are in a piece of water, then we don't explore it. So I guess another thing that we should check is whether we are out of bounds or not. So we're going to be out of bounds if our I or j are less than 0, or if I is greater to or equal the number of rows, because remember, Python is 0 indexed, or if j is greater than or equal the length of one of the rows. So if I is less than 0, or j is less than 0, or I is greater than or equal to the length of grid, or j is greater than or equal to the length of grid sub 0. So these are all the cases that handle whether we're out of the grid or not. Or if the current piece of land is a 0, then we simply don't continue exploring. So, or grid I sub j is equal to 0. And remember that we're dealing with strings here. If it would be an int, then we would simply remove the quotes. And the reason why I put this statement here is also because the if statement is checked from left to right. So all these cases already handle the out of bounds exceptions. If this were to be, for example, placed here, right? In the case that I is less than 0 or j is less than 0, the Python will be like, well, I can't access that. So it'll throw in an error and the code will stop running. So we always need to make sure when doing these problems that we always check the out of bounds exceptions before we actually want to access the grid itself, or a matrix or a list or whatever. So once we check all this, we simply return, so we don't need that anymore. Another exception that we can check, and maybe you guys heard that, I think there's a storm coming next to my apartment. Another exception will be if the current piece of land has been visited. So for example, if we start here and then we go here, right, we're going to check both the left, the right, up, and down. And we don't want to do that again, right? Because if we're here and we check the left again, well, we got here by visiting this first. So there's no reason to visit this first. So if the corresponding entry in the visited matrix is equal to true, then we will also stop exploring. Now, once that is true, that means that we are at a piece of land, so grid sub I sub j is 1, that has not been visited. In that case, what we're going to do is first, we set that entry in the visited array to true. And after that, we're going to call the DFS on the left, the top, the right, and the bottom. So we can say I minus 1, j, grid, and visited. We can do this 4 times. If you want to check a little bit of your knowledge, pause the video because I will also, your knowledge on indices, because I will also label a little bit which one represents what in a bit. So I plus 1, and then j plus 1. So what does this one represent? Remember that the first row here is 0, so I minus 1 will be whatever is above it. So I minus 1, even though it might seem counterintuitive, in this representation means the one that's above. J minus 1 is the one on the left. I plus 1 is the one that's going to the bottom, and that's why I said that it can be a bit counterintuitive for some people, because plus 1 is down and top is minus 1, but that's just the way it is. And j plus 1 is to the right. So we keep calling this, and then the method ends. And now what we will do is just simply call this whenever we encounter a piece of land on the regular method. So for I in range length of grid, and for j in range length of grid sub 0, and this could be length of grid sub I. It does not really matter because the dimensions are consistent within each row. But if it would be a little bit different, like if m wasn't if all these didn't have the same length, then obviously you would need to do grid sub I. So if this is the case, well, first we can say if the piece of land, if the current entry in the grid that we're visiting is a 1, so if it's a piece of land, and that piece of land has not been visited, which means that the entry in the visited matrix is false, then we will call the DFS method, and we will pass the current grid and all the other elements to the DFS method. And once that happens, again, this DFS method takes care of updating the visited matrix and every single thing after that, and visiting every single thing. Once we've done that, we simply increase the island count, which is represented by the toReturn variable. And after we've done all that, we simply return the variable that represents the number of islands. So here, whoops, sorry for that. I meant to do slight error on my part, but There you go. So now we will just run it and test it against the other solutions. And as you can see, I mean, obviously a little bit slow, but again, it depends a little bit on the connection and other aspects. However, like I mentioned before, this solution runs in O of m times n time because we visit every single element of the grid. However, the spacetime complexity of this solution is O of m times n, because remember that we are creating a new matrix that has the same amount of entries, which are represented by Boolean variables in our matrix, as the grid. So how can we make this slightly more efficient? If you want to challenge yourself and think about it for yourself, then pause the video for a bit, but I'll explain now the second approach that I mentioned in the beginning of the video. So the way that we can do this, instead of creating the matrix, is by simply, as we traverse each element, right? Instead of setting the matrix entry equal to true, we can just simply change the numbers from a 1 to a 0 and just completely ignore the Boolean matrix. That way we don't have to use extra space. So how do we adjust our code for that? Well, I will copy and paste it. Okay? We'll comment it and then copy and paste it just so you guys have some, or actually, it does not really matter since you can just pause the video. So what we can do is simply modify the approach by doing this. So we ignore this. We ignore this. And what we can say is grid sub I sub j is equal to 0. We don't even need to pass a visited parameter since we just have the grid, and then we modify the grid as we go. So if this is the case, blah, blah, blah. And now visited equals true, we can just get rid of it because as we traverse the thing, we just change the zeros, the ones to zeros. So this visited thing is pretty much pointless. And it already takes care of visited land to non-visited land. But remember that the input now, the original grid input will be modified. So if you don't want that to happen, then you can use the matrix approach. So we've modified the DFS successfully. And now we can simply get rid of all of this. And also get rid of all this. And this should be the slightly more efficient way of solving the problem. So let's test it. Maximum, let's see, grid. Okay. Sorry for that. The reason why that happened is because I set it up as a number and not a string. Like I said, it can be a little bit tricky sometimes when you deal with these things, but now this should work. And if we run this eventually, like it might be slightly faster. There probably is an iterative way of doing it, which is usually faster. But as you can see, the memory usage has gone down significantly compared to our previous attempt. And yeah, that will be, see, it's slightly faster, like I mentioned before, runtimes and compilations. Well, I mean, Python doesn't compile. Runtimes are a little bit, they're just simply non-consistent. So sometimes an efficient code can be slightly slower than a slightly more inefficient code. But regardless, this would be the way to solve this problem properly and the type of solution that you would want to use in a interview with one of these tech companies that asks you this question. And yeah, once again, the runtime is O of m times n. But now, because we have not defined a matrix with all these entries, our spacetime complexity now is O of 1 because we are simply modifying the original matrix that was given to us. So yes, make sure that you check this problem. There should be related, sorry for that. There should be related questions here. Number of islands to number of distinct islands, max area of an island and stuff like that. So maybe check similar problems if you want to practice this. Because like I said before, I got asked this problem both on my Snapchat and my Facebook interviews. So definitely one to keep an eye on. So yeah, thank you very much for watching this video, and congrats on completing your first medium question on Leetcode. And see you on the next one. Bye-bye.